Now we've worked this out for some numbers, at least on an estimated graph, making it very plausible that the graphs behave in the way I'm going to indicate here. So again, we have power functions, and we have a lesser y factor. I'm going to sketch a power function with a lesser y factor here, then a greater y factor. And then I'm going to sketch a graph of the slope of the tangent line versus x for this graph, slope of the tangent line versus x for this graph. I'm not going to put any numbers on it, I'm just going to do an indication. Now the other thing I'll note is that my y factor for these graphs is always going to be greater than 1. Okay? If the y factor is greater than 1, it's easily seen why and easily proved that the graph has to go through the point 0, 0. Okay, so if we have a lesser y factor that is, however, greater than 1, remember if the y factor is less than 1, the shape of the graph changes in kind of a drastic way. We'll just do one here with a lesser y factor. Okay, and then one, assuming the same x scale, with a greater y factor. And now we want to look at the slopes of tangent lines, and I'm going to use green for my tangent lines. Okay, so I'm going to do a tangent line here, and I'm going to do a tangent line here, and I'm going to do a tangent line here. Okay, so the x coordinates for the points of tangency, which I've just kind of got to estimate here, will be these. And over here, the x coordinates for the points of tangency, well, this graph doesn't extend as far as this one, but I'm going to do a point of tangency right about here at this x coordinate, and a point of tangency, let's say about here, and another point of tangency about here. Okay, what happens to the slopes? Well, in the first place, these slopes are less than these slopes. So we get, if we use the same scale for our slopes, the slope here is probably about 1/3 as great as the slope here, and it's even greater than the slope right here, but somewhat less than the slope, or so, I think I didn't say greater right, but this slope is 1/3 of the slope at this point. It's still less than the slope at this point, but it is greater than the slope at this point. So I'm going to say that whatever the slope is here is going to be represented by this value on the slope graph, and the same value on the slope graph is going to be bigger than the slope here, less than the slope here, and quite a bit less than the slope here. So the slope here is about maybe 3 times as big. So we're going to get a slope here. And now we're going to assume that the slope is 0 when x equals 0 for these graphs. That can be proven. We haven't talked about how to prove it. So that at this x coordinate out here, we finally get up to this slope. The x coordinate of the slope here, well, the x coordinate is going to be about here, the slope is going to be about here. X coordinate here, the slope is still probably at least half as big as the slope out here, so I'm going to do something like this, and I'm going to say that that graph kind of looks like this, and it's concave down. Okay, this one on the other hand, we have a slope that occurs at this point, then at this point, then at this point. We have a slope here that's a appreciable fraction of how of the size of this slope, and then we have a much bigger slope here, and an even much bigger one up here, and it's not working at all. Okay, we're going to kill these.